In this video, we're learning how to simplify square roots that have variables. So let's take a look at example 1, which is the square root of x squared. So remember that if we're trying to find something like the square root of x squared, we're trying to answer the question, what squared is equal to x squared? And we just said it. We said x squared. So the square root of x squared is just x. Basically, because squaring and square rooting something are inverses, they cancel each other out. And you can verify this by saying that our answer of x times itself, right, when we square it, is equal to x squared, which is what's underneath our root. So this fact is going to be very important, that the square root of anything squared is just that thing. We're going to use that to solve some of our other problems. So now let's take a look at example 2, which is the square root of n to the 10th. So we're not going to do this for every problem, but I'm going to explain to you guys how we can find this, and then I'll show you a shortcut. So we're going to rewrite n to the 10th using as many n squareds as we can. So we can rewrite this as n squared times n squared times n squared times n squared times n squared, because if you remember when you're learning exponent rules, when you multiply terms with the same base, so if you multiply like n squared times n squared 5 times, you add the exponents. So if we add 2 5 times, we get 10. So really, we have the square root of 5 different n squareds multiplied together. So now I'm just going to break this up into 5 different square roots of n squared. And from our first example, we know that the square root of anything squared is just that thing. So the square root of n squared is just n. So each of these turns into n. So we're really going to have 5 n's multiplied together. And n times itself 5 times is just n to the 5th. So we get the square root of n to the 10th is n to the 5th. And a shortcut is that if we have an even exponent, so we have this 10 here, and we're finding the square root, we can just cut it in half. So if we cut 10 in half, we get 5, and we could just write our answer like that. So we get n to the 5th either way that we do it. So now let's take a look at example 3, which is a to the 3rd. So this time we have an odd exponent, so we can't really cut it in half or divide it by 2, like I was saying we could do for number 2. So what we want to do is we're going to write this as a squared times a to the 1st, because that's equal to a cubed. So we have the square root of a squared times a to the 1st, and we're going to break this up into the square root of a squared times the square root of a to the 1st. And now the square root of a squared is just a, and we can't simplify the square root of a to the 1st because our exponent is just 1, it's not above 2. So if our exponent is less than 2 and we're taking the square root of the variable, we can't simplify it. So we're just left with this square root of a. So we get a times the square root of a. So now let's take a look at example 4. So now we have the square root of y to the 23rd. I'm not going to sit here and write out a bunch of y squareds to get all the way up to 23 because it's going to take too long. So what we can do is rewrite this as y to the 22nd, because that's the highest even number that goes into 23, times y to the 1st. So I'm going to say that again. If you have an odd exponent, you want to break up your term into the variable raised to the highest even number that goes into that odd exponent. So we're going to break it up into y to the 22nd, and then you're going to have 1y left over. And now we can rewrite this as y to the 22nd in a square root times the square root of y to the 1st. And now here's where we're going to use that shortcut that we were talking about in number 2. So for the square root of y to the 22nd, we can just cut this exponent in half. So it's going to be y to the 11th, and then we can't simplify the square root of y to the 1st, so we just leave it as the square root of y to the 1st, which is the same as the square root of y. So we get y to the 11th times the square root of y. Let's go through some more examples. So taking a look at example 5, now we have 2 variables under our root. So we have the square root of x squared times y to the 16th, And we're going to use the same concept that we've been using. So if it's easier, you guys can think about this as two separate square roots. You don't have to, but for some students that is easier. So we could write it as a square root of x to the 12th times the square root of y to the 16th. And now because we have even exponents, we can just go straight into cutting these in half. So we're going to cut 12 in half, and we're going to get 6. So we get x to the 6th times, and we're going to cut 16 in half, and we get 8. So we get x to the 6th times y to the 8th, and we can just write them without the multiplication sign as x to the 6th, y to the 8th. So now let's take a look at example 6. So this time we have the square root of 25, a to the 9th, b to the 7th. So we have 3 things under our root. So I'm going to break this up into 3 separate square roots. So I'm going to the square root of 25 times the square root of a to the 9th times the square root of b to the 7th. And then underneath, we know that the square root of 25 is just equal to 5 because 5 squared is 25. And because we have odd exponents for our variables, we want to split them up into an even exponent and 1. So we're going to split up a to the 9th into a to the 8th times a to the 1st. And we're going to split up b to the 7th into b to the 6th times b to the 1st. And now we can really write this as 5 times the square root of a to the 8th times the square root of a to the 1st times the square root of b to the 6th times the square root of b to the 1st. And now we can cut the even exponents in half. So we're going to have 5, and if we cut a to the 8th, if we cut that exponent in half, we get 4, so we get a to the 4th. I'm going to cut the b to the 6th in the half and put on the outside. So if we cut 6 in half, we get 3, so we get b to the 3rd. And now we still have this a to the 1st and b to the 1st left underneath our square root. We're going to put those together. So we have a to the 1st, which is just the same as a, times b to the 1st, which is just the same as b. So we get 5 a to the 4th, b to the 3rd, times the square root of ab as our answer. Let's move on to example 7. So this time we have the square root of 40, m to the 10th, n to the 5th. So I'm going to break this up into 3 separate roots. So I have the square root of 40 times the square root of m to the 10th times the square root of n to the 5th. And then down here underneath it on the left, there is not a nice whole number answer for the square root of 40, so we have to simplify this. So remember, when we're simplifying square roots, we need to think of a perfect square that goes into the number under the square root. So we need to think of a perfect square that goes into 40. Now it's going to be 4. So we can break up the square root of 40 into the square root of 4 times the square root of 10. For the square root of m to the 10th, since we have an even exponent, we can just cut it in half. So we get m to the 5th. And for the square root of n to the 5th, since we have an odd exponent, we have to rewrite this as the square root of n to the 4th times the square root of n to the 1st. And now we're going to simplify what we can. So the square root of 4 is 2. So we have 2. We can't simplify the square root of 10, so we leave it as is, times m to the 5th. And now we can simplify the square root of n to the 4th by cutting the exponent in half to get n squared. And we can't simplify the square root of n to the 1st, so we leave it as the square root of n, which is the same as the square root of n to the 1st. And finally, we want to put all the numbers and variables on the outside together. So we're going to have 2 m to the 5th n squared, and then we're going to put everything underneath the square roots together. So times the square root of 10n. Let's take a look at example 8, which is the square root of 72j to the 13th, k to the 25th. So again, let's start by breaking this up into 3 separate square roots. J to the 13th times the square root of k to the 25th. Over here on the bottom left, we need to simplify the square root of 72 by trying to find the largest perfect square that goes in evenly, which is going to be 36. So we can rewrite the square root of 72 as the square root of 36 times the square root of 2. Because j is raised to an odd exponent, we need to break that up. So we're going to break it up into the square root of j to the 12th times the square root of j to the 1st. And we need to do a similar thing for k. So we're going to break k to the 25th up into k to the 24th times k to the 1st. And all of those are under square roots. And now we need to simplify whatever we can. So we can simplify the square root of 36, which is just 6. We cannot simplify the square root of 2, so we leave it as is. The square root of j to the 12th, we're going to cut that exponent in half to get j to the 6th, times the square root of j to the 1st, which is just the square root of j, times the square root of k to the 24th. We can cut the exponent in half to get k to the 12th, and we are still left with the square root of k, which we cannot simplify. And the last step for this problem is we want to put everything on the outside together. So we're going to have 6 j to the 6th, k to the 12th, and everything under the roots is going to go together, times the square root of 2j k. So let's go over 4 more examples just to make sure that we've got this down. So for these last 4 examples, I encourage you guys to try them on your own, and then you can watch me work through them to make sure that you've solved them correctly. So taking a look at example 9, we have the square root of a squared, b to the 14th, c to the 6th. I'm going to break this up into 3 separate roots. So I'm going to break it up into the square root of a squared times the square root of b to the 14th times the square root of c to the 6th. And now I have all even exponents, so I can just cut them all in half to simplify. So the square root of a squared is just a to the 1st, or just a. The square root of b to the 14th is going to be b to the 7th. And the square root of c to the 6th is c to the 3rd. And I'll just write it as a, b to the 7th, c to the 3rd. If we take a look at example 10, we have the square root of 16x to the 17th, y to the 8th. So again, I'll start by splitting this up into 3 separate square roots. The square root of 16 is just equal to 4, so I'm going to simplify that. Because x is being raised to an odd exponent, I want to break it up into the square root of x to the 16th times the square root of x to the 1st. And the square root of y to the 8th is just y to the 4th because we cut the exponent in half. And now I can simplify the square root of x to the 16th by cutting the exponent in half to get x to the 8th. I still have the square root of x to the 1st, which is the same as the square root of x. And I have y to the 4th. And finally, let's just put everything that's not under a root next to each other. So we get 4x to the 8th, y to the 4th, times the square root of x. Taking a look at example 11, we have the square root of 45 m to the 30th, n to the 15th. We can write this as the square root of 45 times the square root of m to the 30th times the square root of n to the 15th. And 45 does not have a nice square root, so we're going to break it up into 2 factors, one of which is a perfect square. So we're going to rewrite it as the square root of 9 times the square root of 5. We can simplify the square root of m to the 30th because we have an even exponent, so we get m to the 15th. And we're going to rewrite the square root of n to the 15th as the square root of n to the 14th times the square root of n to the 1st. And now let's simplify. The square root of 9 is 3. We can't simplify the square root of 5. We still have this m to the 15th. We can simplify the square root of n to the 14th by cutting the exponent in half. We get n to the 7th. And we still have this multiplied by the square root of n. Finally, put everything on the outside together to get 3m to the 15th, n to the 7th, and put everything under the roots together to get the square root of 5n. So we get 3m to the 15th, n to the 7th, times the square root of 5n. And if we take a look at the final problem, we have the square root of 36h, j to the 3rd, k to the 11th. We're going to break this up into 4 roots. Square root of 36 times the square root of h times the square root of j to the 3rd times the square root of k to the 11th. And on the bottom left, we can simplify the square root of 36 because it's just 6. We can't do anything with the square root of h because it's the same as h to the first. So because our exponent is less than 2, we can't do anything with that. So we're going to leave it as a square root of h. For j to the third, we're going to rewrite that as the square root of j squared times the square root of j. And for the square root of k to the 11th, we're going to rewrite that as the square root of k to the 10th times the square root of k to the first. And I should have written this j as j to the first. And now let's simplify what we can. So we can't do anything with the 6 square root of h. We can simplify the square root of j squared, which is just j. We cannot simplify the square root of j to the first, so we'll leave it as the square root of j. The square root of k to the 10th is k to the 5th because we cut the exponent in half. And we can't simplify the square root of k to the first, so we leave it as the square root of k. And last step, we're going to put everything on the outside together. So we get 6j k to the 5th, and we're going to put everything under the root together. So all of that multiplied by the square root of h, j, k. So hopefully this video helped you guys learn how to simplify square roots that have variables. And if you guys want some more practice with problems like this, check the link in the description, and we've linked an actual worksheet with answers that matches this video.